What's up guys? Mga Brad. So ato ang topic nga discuss karon is introduction of delta and Y connection. So wala kaso sa Y connection, Brad, mga ka-Brad. Kay dili kay siya libog. Ari ta mag-focus sa delta connection kay complicated kini siya nya makalibog og kung may resipit, mga Brad, is marong inyong calculation. So let's start. So karon guys, mga kabrad, ato nakita ang illustration mo ni siya ang matawag na single phase transformer. Diri nga side is primary voltage or high voltage, ug diri is secondary voltage or lower voltage. So mo ni siya single phase voltage, mga kabrad. During tag duha ka tuldok or two polarity marks mga indicate nga sa two polarity each side, og natay two magnetic coupling each other na naka-parallel lines. So let's assume nga natay 4160 sa high voltage line to line voltage, og natay 480 volts sa line to line sa secondary nga voltage. So mao lay ito, mga kabrad, natay single phase nga transformer. So ang ato indicate og capital letter ang higher side or high voltage, og lower gamay nga letter ang secondary voltage. So paghimo sa three phase nga transformer, mag-drawing nga patag parehaan mga kabrad. Ato lang siya i-copy. Muna siya transformer B ug transformer C. So nanatay three phase nga transformer. So karon guys, ato i-connect og Y connection ang lower side or lower voltage or secondary voltage. So sayon na kayo ang pag-connect og Y connected. Ato i-connect ang A sa B ug sa C together at sa neutral ari ang center, guys. So mao ni siya nga matawag nga Y grounded nga connection nga ulahi sa to ang characteristics sa Y and grounded nga connection. I-connect ang high voltage or diri nga side into a delta nga connection. So damog pamaagi guys ang pag-connect sa delta connection nya. Natay sayon nga pamaagi sa pag-connect sa delta connection. Matawag ni siya og delta AB connection or delta Y1. So ninaon siya pag-connect guys, mga brad, in such. So mauna ni ang delta connection guys. So overall guys, matawag na siya nato og delta Y three phase transformer grounded connection. So continuation sa ato ang discussion, mga kabrad. Let's discuss about the phase voltage and line to line voltage. So phase voltage ato nasabtan nga mo siyang voltage nga measured across the transformer windings. Example ani is primary phase A. So para sa tanan primary phase B o primary phase C nya. Para sa there is a secondary winding, primary na secondary, I mean phase A secondary, phase B and secondary phase C. So muna siya ang phase voltage. So mag-topic sa line to line voltage mga kabrad. Muna siya ang voltage measured across two lines. Example ani, common example is voltage line to line voltage A connect to B, yeah, line to line voltage B connect to C, yeah, line to line voltage C connected to A. So arita brad, so arita sa tong primary nga winding nga nakakonect siya og delta. So sa relationship mga kabrad, ang line to line voltage primary A ug B ato siya i-connect, ang sa relationship is equal ra sila sa phase sa primary phase A. So muna siya relationship mga kabrad nga ang line to line voltage is equals to phase voltage. So sama ra na sa tanan mga kabrad. So ang line to line voltage primary B ug C is equal gihapon siya sa phase voltage na primary phase voltage B. So sama ra po na siya sa line to line voltage nga primary CA is equal sa po na siya sa nga primary phase C nga winding. So muna siyang relationship mga kabad. Ang balikon is kung delta connected siya, ang line to line voltage is equals to o equal ra sila sa phase voltage. So naikalahian sa kining Y connected guys, kay sa relationship or equation sa kining Y connected, ang line to line voltage is equals to square root of 3 kinaka 3 phase times phase voltage. Muna ya equation guys. Kung ato ning kuan sa madahon mo man siyang common nga kining connection. So line to line voltage A ug B. So sa pagkuha ani guys, nanayon ni siya. So ang voltage secondary voltage secondary phase A is minus to secondary phase B. So parihar na siya tanan guys. Ang kining secondary line to line voltage B ug C is equals ka po na siya sa secondary phase B minus secondary phase C. So muna siya ang equation guys autotrohon sa Y connected is yung equation is line to line voltage equals to square root of 3 times phase voltage. So for example guys, ang artist sa primary nga voltage. So sa naging nga topics natay line to line voltage nga sa primary nga 4160. So muna siya ang line to line voltage sa A ug B. So sa ato ang line relationship kaya ato ingon kanina, so equal siya sa phase. So kung ang A ug B line to line voltage, so ang phase sa A is equal sa gapon, so 4160 nga voltage. So sama ra na siya sa voltage phase B o voltage phase C primary. So kung ari ta sa secondary nga volt mga kabrad, so natay line to line voltage nga 480 nya aton tigaman nga naka Y connected siya. So yung equation mga kabrad is line to line voltage equals to square root of 3 times phase voltage. So unsa man ni guys or mga brad. So ato lang imagine nga sa 480 mo to line to line voltage. So natay 480 diri yeah, square root of 3 phase voltage, no? So line to line voltage. So ato na siya i-calculate, ato lang kung madali lang i-shift solve na siya. So magawas ani nga kuan nga kabrad, answer ani is 277 volts. So mo na siya ang ato ang answer sa secondary phase A, 277 volts sa iyaha line to line voltage A connect to B. So sama ra na sa tanan guys, kay mura man gapon ilahang line to line voltage is 480. So kini siya ang secondary phase B 277, ang secondary phase C is 277 volts. So arita continuation siya sa ato ang topic. Magkuha na po ta sa current nga relation. So pasabot ta mga kabrad nga ang secondary nga voltage o secondary winding is naka-Y connected siya. So ato topic ron is about line to line current. So nasabot ta nga ang line to line current is flow through the lines or the conductors niya. Kasabot ta nga ang kaning secondary nga voltage is load side siya. So ato assume nga ang line current is will flow to line A nya parehara po na siya nga sa line currents B will flow to B padung siya sa load nya. Ang line current C is padung siya sa line C, padung siya sa load. Arito sa ato ang kuan mga kabrad sa high voltage kabot ang high voltage is gikan sa source such as generator. So iyang line to line current is line current A is padung sa high nga voltage is padung ato sa load gikan siya sa source. So pareha lang sila sa line current B padung gapon sa source ug line current C gikan sa source padung gapon siya sa load. So arita guys, no? Sa secondary nga voltage nga kabota nga naka Y connected. So we all know that phase current is flow through transformer winding. So sa relationship guys sa Y connected, we all know that the line current is equals to the phase current basta naka Y connected siya. So ang phase current A gikan sa ato ang A winding padung sa tuang load parehara na mga kabrad. Ang phase current nga B gikan sa atong B winding padung sa load ug sa C parehara ang phase current sa C, gikan sa C winding padulong sa ato ang load. So ato tigaman kung nakaway connected guys, ang line to line current is equals ra siya sa phase current. So arita sa kuan guys sa high nga voltage or sa primary voltage, no, as we all see nga ang secondary voltage or secondary nga phase current is pagawas siya sa dot. So it means nga ato ang primary nga phase current A, kung pagawas ang secondary, so pasod siya mga kabrad. So ana siya, so pasod iyahang primary current phase current. So sama ra po na siya diri sa primary as primary B phase current, no. Ang secondary pagawas siya sa dot, so ang secondary pagawas, so ang primary is pasod siya sa dot diri. So primary phase current P o primary pasod siya phase current C. So mao na siya ang relationship guys sa current, no, sa line to line current ug sa phase current. Continuation guys, no, sa atong topic itong aging nga discuss about sa introduction sa line current o sa phase current. So sabot sa atong agi nga ang primary nga phase current A, B primary phase current B ug C is pasod siya sa polarity sa high or primary windings. So kuan sa secondary is pa-out siya, no, ang phase current niya sa ang A, ang phase current nga B ug phase nga current nga C is pa-out siya sa polarity sa secondary winding. Discussing about mga kabrad, our relationship sa phase current o sa line current, no. So sa Y connected mga kabrad, we all know that sa equation niya ang Y connected jud yang line current or in other word line to line current kung asa mo sa yun is equal gid siya sa phase current, no. Pero arito sa delta mga kabrad, yung equation gud sa ato nang sabta, no, sa topic nato is atong gitakol nga mga topics, ang line current o phase current is dili equal, no, basta naka delta. So yung equation, no, aron sa inyo nasabton mag-solve ta, ang line current is equals to square root of 3 kaya naka 3 phase man ta, 3 phase generator times phase current, no. So kung ato na siya example ano mga kabrad, ang line to line current is 1 ibot ka nato og 20 amperes, no. So 20 ni dire 20 amperes, so divide 3 square root of 3 phase current. So kung imo na siya isip solve mga kabrad, so ang mogawas ana is po ang answer mga kabrad. Mao na siya ang relationship sa phase current o sa line current sa naka delta connected, no. So ang equation niya is line line current equals to square root of 3 times phase current. Yeah, sa Y connected, the equation is ang given nga kung given nga line current is equal siguro na siya sa phase current. So mura na siya ang relationship guys. Continue ta. So mo na ang continuation. So mo na ang itong naaging nagkwanta sa node A1 og node B1 og node C1. So karon guys, mo na nato ang equation guys no. Atong nahimo. Line current A plus phase current C equals phase current A. So mo na ato ang equation nga na resulta sa ato ang niaging nga mga topic. So kini siya guys, ato ani siya i-write no nga equation. So ang kaning phase current C is ibalhin ngadto sa pika side. So pareha ani line current A equals phase current A minus phase current C. So sama ra na sa uban guys sa line current B ug sa line current C no. Makita nato sa illustration. So mo na ni ang ato ang gi-rewrite nga equation gikan atong taas nga equation. Next is nakakabaw to sa relationship sa phase current no. Asa padong siya nga node asa pod sa mga sa phase current B ug sa phase current C. Asa sila nga tuyok pa inward sila. So there guys, ang phase current A is equals to 1000 A angle 0 degrees. Ang phase current B equals 1000 amperes angle 240 degrees. And phase current C is equals to 1000 amperes angle 120 degrees. Muna siya ang illustration guys no. Ang ato aning sample or ang written example. So karon guys, maghimo ta og pressure nga diagram. So nara to equation guys, no? Natay Y connected dere. So muna to ang reference no. So kani nga line guys is at matawag na 0 degrees ni siya dere nga matawag nato og phase current A nga naka 0 degrees. Og siyang tip to tip is 1000 amperes. Makita nato sa taas nga equation. So dili pod nga side guys is ang phase current B nga sa tip to tip or nakasukod siya og 1000 amperes no. Ato makita sa equation diri sa taas. So siya padulong sa A to B is counterclockwise nga sukod siya og 240 degrees no. Makita nato diri no sa taas nga equation. Susunod diri nga angle guys is phase current C no nga tip to tip measure gapon siya og 1000 amperes. Unya i-counterclockwise no, i angle is 120 degrees angle. So mo gapon na ato makita sa illustration nga nasa taas. So overall guys, mo na siya ang pressure diagram no sa equation sa taas. Okay, so we're going to take this pressure and subtract phase A current with phase C current and then look at what our line current A looks like. So here phase A current and here is phase C current. Now if we want to perform phase A current plus phase C current, we would this through what we call the head to tail method. And how that work is very simple. We would pick up phase C current and add it to the head of phase A current, and the result vector starts from the origin and towards the head of phase C current. So this is right here is our resultant vector, and this resultant vector equals a phase A current plus phase C current. However, this is not what we want. What we want is to equate is the equation phase A current minus phase C current. Let's clean up this mess. This current back to where it was. Okay, because there is minus sign that's associated with the phase C current, we have to pick up phase C current and rotate 180 degrees. So phase C current becomes like this. So this phasor here is negative phase A current. So now let's pick this up and again connect it to the head of phase A current. So now we're going to connect it like that. Okay, now the resultant vector starts from the origin and ends at the head of the negative phase C current. Now notice that the resultant vector longer now, right? At the resultant vector represents phase A current minus phase C current. Now believe it or not, this phasor diagram actually represents this particular equation, and this resultant vector is actually representing this line current here. So what we're saying to say, when comparing line current with phase A current A, now remember this is phase current A here and this is line current here, so it's labeled that a little better. We see that the line current is a longer larger than our phase current, right? This is our phase current here and this is our line current. So the magnitude of our line current, which starts from the origin and ends at this tip here, that is a lot longer than our phase current. In fact, if we compare the two, we will find that the line current is actually the square root of 3 times larger than our phase current. So if we take our phase current here and line it up with our line current, we would be at this point here. But then we would have to stretch it, or we would have to multiply it by the square root of 3 or 1.73 to make it equal to our line current. So the first observation, the line current is the equal square root of 3 times larger our phase current. Now also notice that our line current has phase shift associated with it. So if the phasor were rotating in the counterclockwise direction, which this should according to international standards, they are rotating in the counterclockwise direction, we will see that the line current has 30 degrees phase shift. So number 2, line current has 30 degrees phase shift with respect to phase current. Line current has 30 degrees phase shift with respect to phase current. When I first learning this particular phase analysis was really complicated. It didn't sit with me very well. So let's take a quick step back and walk through this step by step. So what we're actually doing with this phasor analysis is we're trying to compute this particular equation, and what we're saying is if we subtract phase current A minus phase current C, we'll get line current A. And this is exactly what we did. We took phase current A and we subtracted phase current C, and what we got right here is line current A. All we're saying is that if we compared phase current A, which is phasor here, with line current A, which is phasor here, we'll see that the line current is not larger than our phase current. Not only it is larger, but it is also has 30 degrees phase shift. This line current has 30 degrees phase shift. So going back to our diagram, what we're trying to say is that this line current here, ug ato ikumpara this line current with this phase current, which is the phase current that flowing through the primary phase A winding, this line current is going to be square root of 3 times larger than this phase current, and this line current is also going to have 30 degrees phase shift. Continuation guys, no, sa topic na makita na sa part 2 sa maong video nga atong gidiscuss siya. So ang line voltage o ang phase voltage, no, sa delta mode o naka-delta connected is equal siya, no, ato siya makita nga ang voltage AB, line voltage AB is equal sa kapon sa phase voltage A, no. Og kining sa voltage nga line voltage BC is equal sa gapon siya sa voltage phase voltage B, ug sa line voltage nga VCE is equal sa gapon siya sa phase voltage sa C, no. So current video we will talk about quantities on the delta side. Now to begin, let's clarify something. The delta has no ground, right? But there is ground somewhere in our source. Kasagaran generator in our source is tied to ground. kana nga ground is the reference for this transformer. So we're going to assume it's this particular connection. So now that the ground is, we know that the ground is for the source, and we know that this ground is in reference to this particular delta connection. So now that what I'm going to do is I'm going to connect this ground to the Y side, and I'm going to say that it's all the same ground. Now that I have that established, I have the same reference quantities established. What I'm going to say is that the voltage across line A and this ground point here, if I measure the voltage across the line A and the ground pit here, I'm going to call this voltage VEG. I've drawn the arrows here to indicate that. Now VBG, that's going to be measured across the line B and ground. So we're going to add arrows to illustrate that here. Okay, there is VBG, and lastly VCG is the voltage across the line C and the ground. Now the trick to understanding voltage pressure for the delta connection is really rooted in the understanding of the equation VEG versus VEB. So VEB is the voltage across the line A and the line B, which is essentially equal to phase A voltage. So we're talking about the differences of understanding phase A voltage versus VA voltage. And oftentimes this VG quantity is also called VEN, and is also referred to as this reference quantity. Okay. So naagi nga topic guys, we set up our voltage measures and we define VAG, VBG, and VCG. We also say that this is a difference between VAG versus VEB or VE, and that is the key to understand voltage pressure for the delta connection. VEB, which is the voltage across line A and line B on the delta side, is equal to the phase A voltage, which is the voltage across winding A. That is also equal to VEG minus VBG. AAG is here, which is the voltage across the line A and ground, and VBG is here, which is the voltage across line B to ground. So the voltage across line A and line B is essentially equal to the voltage across line A and ground minus voltage across line B to the ground. So let's evaluate this equation. So I've set something up early. This should look similar to the examples that we've been doing in the previous tutorial. The first thing that we're going to do is that we're going to define our phasor values. I'm going to choose a value for VEG of 2000 volts at 0 degrees. VBG is again 2400 volts at 240 degrees, and VCG is equal to 240 volts at 120 degrees. So I'm going to go to this phasor VEG. So VEG is at 0 degrees, and 0 degrees is my reference line. VBG is in this phasor here, and VCG is in this phasor here. So this right here is an ABC phase rotation. Now we said in our equation that the line to line voltage across the line A and line B, which is essentially the voltage across phase A winding for the delta connection, is equal to VEG minus VBG. So here is VEG right here. We're going to perform the head to tail method and subtract VEG minus VBG. Okay, so now that we have a visual representation, if we were to relate VEG to VEB, what we have to do, we will have to shift VEG by 30 degrees in the counterclockwise direction, and then we will have to multiply it or stretch it by 1.73 or the square root of 3, so it lines up with VEB. So we take VEG, now we have to shift VEG by 30 degrees in the counterclockwise direction, and we have to multiply it for the stretch it by 1.73, so it overlaps VAB, which means that VAB is equals to the square root of 3 times VAG rotated by 30 degrees. So this equation here, let's step back and understand exactly what's going on here and why doing this. We want to understand the relationship between VAG and VAB, because that's what's going to help us understand the voltage spatial diagram for the delta connection. Sa nayaging discussion, we concluded that VAB, which is this voltage spatial here, that is equal to VAG, which is this voltage spatial here, rotated by 30 degrees and then multiplied by the square root of 3. That's going to equal VAB. So let me write that down here. So VAB is square root of 3 times VAB by 30 degrees. I'm going to extend that concept to evaluate VBC and VCA. O makita ni nga pareha ani. So this picture here is negative VCG and this picture here is VBC. So what we're saying is we take VBG, we rotate it by 30 degrees in the counterclockwise direction, and then if we multiply by the square root of 3, that's going to equal the VBC. Similarly, we're going to do the same thing with VEC. So over here, VEC is negative VCG. We take VCG, rotate it by 30 degrees in the counterclockwise direction, and then multiply by the square root of 3 to equal the VCE, which is the picture here. So now we have the line-to-line ground voltages.